Hello guys, welcome back to another video. Today we are going to solve another exercise in limits theory. Today we have a function f that goes from r to r, where r is the real numbers. The exercise gives us a given limit that is the limit of x multiplied with f function plus x squared minus 8 when x tends to the number 2 is equal to 6, and the exercise wants us to find the limit of the function f when x tends to 2 and the following limit that we see over here. And we will first calculate this limit over here. So when the exercise gives us a known limit, the first thing that we always do, step number 1, is to set whatever there is inside this limit equal to a function, let's say g. So we will write function g is equal to x multiplied with f plus h squared minus 8, and from this we can understand that the limit of x when x goes to 2 of the function that we already set over here, g is equal to 6. So we know the value of the limit of g, that is equal to 6. Let's call this equation number 1, and this over here number 2. The next step that we are going to do, guys, is to solve the equation number 1 in terms of f function. So we will able then to find the limit that we are asked for. So we will write over here, and then we want to solve it in terms of the function f, but we will meet a little bit problem here because we don't know if x is not or equal to 0, so we can divide with x to leave the function f alone here. But in this exercise we are only interested when the x tends to 2. So we can definitely write that x is not equal to 0. So we can divide with x. And we will have the next f function. This is what we did here, in case you didn't understand. We divide with x, and we will have this function over here. So we found the function f. And next thing is to calculate the limit of the function f when x tends to 2. So we will have let's call it equation number 3, and this due to 3 will be equal to this one over here. Here we know from this over here, from the exercise, that the limit of g when x tends to 2 is equal to 6, so we know this limit too. It's a simple limit, we don't have any indeterminated form because it tends to 2, so we will do just the replacement, x equal to 2. 6 minus 2 squared plus 8, 2, so this will be 6 minus 4, 2, 10, 2, 2 equal to 5. So the limit of function f when x tends to 2 is equal to 5. So we found the first thing that we are asked for. So the next limit that we are asked for to find is this. Here our job is easy because we only have terms of f function here, and we have found the limit over here when x tends to 2 is equal to 5. So the thing that we do in this kind of limits is to set the function f equal to a variable, let's say y. So we set y equal to f. Next thing is to find y goes when x goes to 2, because here we have x goes to 2, and this we will do it by writing and we have already found this. It is equal to 5, so we will have limit of y tends to 5, because this is what we found here, when x goes to 2, of y squared minus 5y 2 y minus 1 minus 2. As we see here, the denominator, if we do the replacement of y equals to 5 in order to solve this limit, will be 0, and the numerator will be 25 minus 5 multiplied with 5. 25 minus 25 will be a limit in a indeterminated form of 0 to 0. So this is a problem and we have to solve it. The way you solve this limit is quite easy, because we have here this over here, and what we are going to do is to multiply the numerator and denominator with the adjoint representation. This is a typical way to solve this kind of limits. So we will have we multiply the numerator with the same thing, square root of y minus 1 plus 2. This is the adjoint representation. And here we will have the previous denominator multiplied with the same. 1 plus 2. And this will be equal to the square difference that we know for the little classes, minus 2 squared. This and this go will be equal to this. So the result will be the limit equal to 20. So that was the video for today, guys. If you liked the video, please drop a like below and see you guys in the next video.